Hi, everyone. Thanks for coming. My name is Ayşegül, and I'm here to talk to you about AI and 3D using WebGPU. You are in the right place, I hope. Today's agenda, we are going to talk about what the WebGPU is and the AI overview on the web. And I'll show you some demos and show you how they fail. And at the end, I will talk to you about how to build better experiences for WebGPU and AI because there are lots of gotchas, unfortunately. A little bit about me. I'm a co-chair at W3C working on immersive web, WebXR device APIs. And WebGPU is very important to us. And I'm the founder of ARtistus. And you can find me anywhere with AYS something, because it's really hard to pronounce my name. Spelling is even harder. Has anyone seen Sarah Dresner's talk? Oh, yeah. It was a great talk, and she had great visuals, and she let me use this one. So she talked greatly about what are the differences between GPU and CPU. So basically, the important part for us is there's an event loop that's happening all the time, and CPU is trying to decide what to do next. And if you give it a big function, something to do for a long time, we block everything, and even a button click freezes out. So for things like bigger compilations and calculations, we have WebGPU. It's kind of like a minion which is super powerful. You just tell them what to do, and then it just does it over and over again. WebGPU is a very new API, also developed at W3C WebGPU working group. And it is hoping to address newer GPUs and replace WebGL. So if you are familiar with WebGL, this is how we draw things in Canvas. It has fragment shaders to make things colorful and vertex shaders to make, put 3D objects in 2D space. But modern GPUs has more to offer to us, so we felt the need to have new APIs to directly address them. So it's a very low-level API, and most of us are not going to use it directly, but there are lots of libraries that are using it and utilizing it for us. It has better performance and less overheads. It's using the resources a little bit more better. And the other important part, especially for us, AI developer, is the compute shader, which we did not have with WebGL. So what compute shader does is if you give it some instructions, it runs that instructions over and over again many times. You can just think of it as a fancy each or array loop functionality, basically. And it has the modern features, and it has more storage, and working with it is a little bit easier. Currently, we have support for 70% coverage for the browser across, but there are always newer features that are being added every day. So it's very, very new, so be patient with it. They're still developing the spec and implementing it slowly. But you can have the basic implementation right now. And why this matters for AI? Because GPU is, as I said, very good with calculating things over and over. We have a benchmark over here comparing the WASM with GPU. I'm going to start it, and it starts calculating. I'm not sure what it's calculating right now, but. So the light green is WASM, and dark green is WebGPU. As you can see, over time, the difference in time goes up and up. For the logarithms algorithms too, WebGPU is doing a way better job. All right. Also, as I mentioned, we have 4 times more storage buffer, which makes things easier for us. And inference of speech vision transformers running kind of larger AI models is very fast. More importantly, it has 0 server cost. When you're running the same AI on a cloud service, like Google Cloud or Azure, you also have to pay for a server that is going to run your models, and that has a cost, and it increases when your audience increases. And I think this is the most important part. We have complete privacy when we run the things in our own machines. So with WebGPU, we are running, we don't have to send data anywhere, and we can run the model in our computer or in our phone. That means we don't have to share the data. Nobody has to know, which is a huge thing. And some of the problems with traditional cloud AIs, there's a latency. Every time you make a network call to the API, there's a cost to it. But at the same time, I have to say, they are really, really fast. The cloud computers are way stronger than your phone or your laptop most of the time. As long as you have good Wi-Fi, they are pretty fast. But the privacy concerns are more important when it comes to AI. So many people are using the LLMs right now, which seems like, okay, you can control what you're sending, you know what you're saying, but when you start doing something related to images, privacy becomes an even bigger concern. Cost at scale increases drastically, and also you are dependent on a server, and the service rules change, there's outages, and documentation changes, and things break, and the documentation is usually not very good. There are also rate limits. When your app is using a lot of data, sometimes you get throttling and you have no control over it. So when we are using client-side AI with WebGPU, there's 0 latency because we're not making a network call, we're running it in our computer. There's complete privacy, no API costs, no rate limits. And okay, so it's great, but how do we get started? You might have heard TensorFlow.js. How many people heard it? Yeah, a lot. Great, awesome. There are other libraries now. WebLLM is another one. Transforms.js is the one that I'm going to show you today. How many people heard of Transforms.js? Less. It's made by Meta, but it has great documentation and really good community. These are the places, these are the libraries, and you can also train your custom models and use it with these libraries with tools like Teachable Machines from Google. Basically, this is showing how to train for images. And like in this one, you can classify things from your webcam or send an image. All right. We also have Hugging Face WebML community. Hugging Face is kind of like a GitHub for AI ML on the everything that's related to it. And we have a great web community called WebML community where you can find most of the AI models and play with them a little bit too. Okay. Transforms.js is JavaScript. It has trained models already, and if you can't find the model that you're looking for, you can find a trained model somewhere else and then transfer it with the Onyx runtime to be used with Transforms.js. It has a very simple API. I mentioned bad documentation. This time, this is really actually this simple. We just import a pipeline functionality, and then we tell it to what our intention is, which is the translation, and which model we want to use. And this is the initialization, the whole initialization that's going to happen. And it works exactly the same way for image detection or any other thing that you're looking for. All right, let's do our demo. Oh, yes. Okay. Let's start translating. Okay. So I have two different translations. I'm using Web's speech API to get my turn my speech into text, which is a native API. And then I'm using that with our model. So this CPU is taking less time, translating it with CPU is taking less time than the cloud. But this is, as we mentioned, very dependent on the network capabilities. So if we demonstrate kind of beds, where's my network tab? Do you guys see it? Am I not seeing it? Oh, yeah, it's right here, throttling. So if we show worse, well, 3G is kind of a little bit worse. Translation slows down way more, I'm going to say. Are you going to translate what I'm saying? Okay, wait, it didn't slow down. But if we turn it off completely, hello, hello, hello. Okay, how is that possible? We are offline. Oh. Hello, can you translate? Well, it is making up stuff, for sure, but I'm not sure how it's doing it because we are failing it. Let's start it over. And pray the demo gods. We are offline, so our app is not going to load. All right. Hello. Does anyone speak Italian? Oh, wait, I was looking at the wrong one. Okay, the first one is CPU, so it is happening. Why aren't you guys saying anything? Come on, help me out here. All right, so, wait, it did start translating again. Okay. Believe me, it's not supposed to, but something is happening. I don't know why. All right, let's go back to Reveal.js. All right, so we said that this is running on the CPU, and let's look at the WebGPU documentation and see how we can run this thing in GPU. So it says, thanks to our collaborators, enabling WebGPU acceleration as simple as setting device to WebGPU. Let's give it a try. All right. Let's see if I'm... Okay, here is my pipeline running, and I turn on the WebGPU. But let's see if this time things do run. Come on. All right, so we are getting an error, and we are not even getting the error message, actually. All right, well, demo gods are not with me for sure. What happens here is we just follow the documentation, we just turn on WebGPU, but we get an error because the model itself is not WebGPU optimized. And documentation sometimes lies to us. This happens, friends. What you can do is in Hugging Face, you can look for models especially and search for WebGPU specifically to find all of the models that are available that uses WebGPU. And additionally, you have all kinds of filtering options. We can do text-to-speech translation, and then we can choose the library that we want to use it with as well. I am online, right? Okay, there is no translation. Carry on. All right. So let's talk about the challenges of the client side. So the models are really, really big. One big problem is loading them. So we are doing this just once and then saving it on our device, and we don't have to do this over and over again, but it's, as we all know, it's a really bad experience when people wait for things to work. So we have to be careful about that. There's also a huge variety of devices out there, and we don't know if the device capabilities of our users most of the time, and you really have to plan, depending on your application, if it's going to be used in a phone or in a desktop. You really have to choose your models. So one way to do it is also choosing smaller models instead of larger models, of course. Browser support, we are not completely there yet. There's still 30%, and there's memory limits and restrictions. So we do have access with the WebGPU device APIs to the GPU, but the browsers are deciding which GPU we are going to get and how much memory usage we can have. So we don't just take over the device of the user or spend all of their battery. And there's a little bit of complex tooling and not enough tooling at the same time because it's a very new web API. And we have a couple of ways we can deal with this. We can load the models progressively. We can always cache the models locally. And quantization is the most important part of it. Quantization means making the model smaller, basically. We have a couple of options. Q4 versus Q8 changes our model size 4 to 8 times. And we can go, if we are sure that our users are just using it in a work environment on their laptops or desktops, we can use the larger quantization models like F32 and load a larger model. But larger model doesn't necessarily mean it's more efficient. And it very depends on your use case. For example, if you're looking for something, if you're doing image recognition and looking for something very specific, you might want to train your model, you might want to have a bigger model, but if you're looking for something very simple, like a dog or a cat, you don't need the most complicated AI models. And finally, we can use web workers to make our application do the downloading of the AI models in the web worker. Also inference, we can do that in our web workers so that our main UI is not being blocked. And lazy loading is another option. And let's talk about the limitations. We mentioned the shared resources. You can't just get a hold of the whole GPU and monopolize the whole computer. We have some limits. We have privacy restrictions. We can query our GPU because we don't want to give access to the developers that will let them do fingerprinting and know more about the user than they need to. We have some boxing constraints. This is a general problem or functionality feature of web, we could say. Because we want to make sure web is a secure place for everybody, we do sandbox things, and we don't give every functionality that, unfortunately, native apps have. But your code works reliably on all of the browsers. That's what the W3C specs guarantees for you. And testing our application is very important. Since we can have all of the devices, all of the GPUs to test on, there are some companies that you can test it for, but it's still not the most, you will not get information from every kind of device. The better use case is getting user telemetry from your own users, so you know the real use cases and how it's failing or succeeding. We can always do progressive enhancements. We can always fall back to WebGL if we need to, and check our features are available in advance. And also think about the most common use cases. If it's for a low-end mobile that is going to be used all around the world, then you have way more limitations. And let's talk about the real-world examples that we can create today. We can do image generations with AI. We can do text generations. We have captioning, as we saw. And then for games, we can do procedural content generation, like the environments and the textures. And the other important thing is we can do search functionality for medical documentations. And I think this is a very important use case since it requires a lot of privacy. Education assistance and creative tools are the other ones. All right, this is the AI use case of the WebGPU. And of course, WebGPU is going to be used a lot with 3D graphics. It's going to allow us to have a better rendering, much faster rendering. One of the issues that we are running into with WebXR also is the quality of the applications, and the visuals are not as great as a native game. I don't think it will ever be exactly the same level, but we are getting really close. We can use the compute shaders for things like physics and particles and simulations, and that allows us to create a lot of different applications and experiences too. And we have ray tracing coming up, hopefully, and people are building ray tracing extensions, which allows us to create better lighting situations and calculate real-world lighting situations. Basically, what we are doing is sending a ray from our light source to everything in a 3D environment and then calculating it. And it's been a really hard thing to do with the WebGL, but now we have WebGPU. All right. Some of the things, as I mentioned, we can create real-time textures, real-time environments, and 3D models from images too. So if you come to the spaces option for Hugging Face, you can search for 3D modeling or image to 3D. And you have all kinds of really cool tools that you can play with. And you can actually generate the shape from an image. As you can see, this is a 2D image, right on your browser. And create the 3D mesh, which has been the hardest part for developers to find or learn about 3D assets, now it's way easier. Let's see. Okay. And these models can look very simple, but can get really big. We do have lots of options to make it more complicated or simpler over here, too. We can do also style transfers. What we mean by style transfer is basically filters that we already have for things like Snapchat. But we can do that in the context of 3D to the whole environment, which is really interesting. We have neural radiance fields, NeRF rendering, which is, again, taking multiple images from a real environment or generated environment and creates some 3D environments. So this is a really cool example that came recently, and this is not available on Hugging Face, unfortunately. But these are all generated images from like an AI tool like Midjourney, and then everything is turned into a 3D splat in this case, which is a newer technology, and you have endless possibilities for a games environment, basically. All right. And I think future is brighter than now, for sure. Please be patient with these newer web APIs. It really takes us way longer time to develop the web APIs because we do really care about the privacy. And the browser teams are doing their best to implement all of the features that people are looking for. We will have more quantized models in the future, and there's a lot of research going on right now that shows quantized smaller models sometimes do a way better job than the larger models, and that is really hopeful. So that will make our apps way better too. And ray tracing is something that people are working on. I would like to leave you with some resources. The WebGPU.io has all of the information to the W3C WebGPU working group resources, and all of the discussions are happening there. If these are some important features for you and for your company, I strongly recommend you join the conversation and take a look at the issues that are there, or suggest your own issues. Transformers.js link, and Onyx, as I mentioned, allows you to take models from anywhere and then turn it into a format that can be used with Transformers.js. And WebGPU Fundamentals, finally, is a great website which has all kinds of information as deep as you want to go if you are interested. And we have tons of examples on GitHub. And the demo you can find here if anyone is interested. And now it's your turn to try out, and please do let us know what you are building, and anytime you have any questions. Please start small, like image classification, sentiment analysis. Anytime somebody asks me about a project, it's usually, the problem is it's very enthusiastic and overly complicated. Starting small is great, and you really have to try out different models and see their weaknesses and powers. Do have progressive enhancements. It's really awful when you go to a website hoping a feature, and it's because your browser doesn't have the capability yet, you have no way of seeing it. That happens a lot with Safari, unfortunately, but Safari is dedicated to add WebGPU as well. And share your learnings. This is a very new technology, so this is an opportunity for everybody's career to get into it early on and experiment on things. And join our community. We have a Reddit community, and we have the GitHub discussions. And that's all for my presentation. And I'm on time, but I'm happy to answer any questions that you might have here or outside. Thank you very much for your attention.